Hi, my name is Dave Cranage, Field Sales Engineer for Sage X3 here in North America, and thanks for joining me for this session. This session is the third in a series of sessions covering key concepts and the capabilities of Sage X3's web scheduling. The session will build on several concepts introduced in the previous two videos. If you haven't watched the first two videos in the web scheduling series, please go back and review both sessions before continuing. In today's session, I hope to achieve several outcomes. I want to review the concepts of changeover and optimization and the impact they can have on your manufacturing environment. I want to introduce you to X3's new setup matrix and review the configuration necessary to enable the setup matrix functionality. I want to show you how the setup matrix configuration translates into the grouping and optimization available within web scheduling, and how that can affect your manufacturing efficiency, capacity utilization, and throughput. Finally, I want to introduce you to the book, The Goal, which outlines the theory of constraints and delves deeper into the concepts we discussed today. In session 2 of our web scheduling series, we introduced the concept of capacity and how X3 and web scheduling team up to define and utilize an enterprise's finite capacity. But as the name implies, finite capacity means we only have so much. A key method for getting the most out of our available finite capacity is through changeover time reduction or optimization. Schedule optimization is the process of making sure each individual operation or task on a schedule is aligned with your goals. These goals may vary from one manufacturing environment to another. They may be maximum throughput, guaranteed on-time delivery, highest quality, allergen safety, seasonal products, or short-run or personalized products. In the end, each environment is looking for the control and flexibility that having enough, and not too much, available capacity allows them to meet those goals. Before we look at the impact that changeover time reduction can have on a manufacturing environment, let us review the concept of changeover time. Changeover time is defined as the time elapsed from the last good part of the previous run to the first good part of the following run. Often, changeover time and setup are used interchangeably, but setup time is simply a component of changeover time. In a perfect world, we would have absolutely no changeover. However, the reality is that is seldom the case. The entire changeover time also includes cleanup procedures for the previous run, as well as startup procedures for the next run. Changeover is not a simple process. We don't just stop and then start again. It is more complicated, and it is also disruptive. As the stages of changeover diagram shows, changeover can be broken down into more subtle stages. During changeover, you lose production cycles or throughput. These are pieces that would have been produced if the changeover had not occurred. This is illustrated in the diagram by the ramp down, process stopped, ramp up, and quality loss. You also lose additional production time in the form of the pre- and post-changeover steps, as well as the actual changeover itself. This is illustrated in the diagram by the preparation, changeover, wrap-up, and any subsequent quality checks. Reducing the overall time spent on changeover by recognizing and improving all stages ends up saving time and money while improving throughput. When analyzed in this way, it becomes clear that managing and reducing the impact of changeover can drastically impact manufacturing productivity. So what's all the fuss? How big a deal is this reduction in changeover time? Well, a simple reduction in switchover time can increase throughput, reduce wasted time and materials, reduce inventory and work in process, improve responsiveness to customer demand, and improve customer satisfaction. In addition, reducing changeover time can lead to the reduction of capital equipment expenditures, use of subcontractors for overflow, reduction of temp staff, and a potential reduction of overtime, all of which can have a direct impact on the bottom line. Let's review a simple example. Say, for example, that your current changeover takes an hour. Assuming you're running 5 to 7 per week, that's nearly 1 day a week spent running changeovers. At a minimum, you could be wasting 32 days on changeover time per year. Imagine what you could do if you got even half of that back. Sage X3's planning tools can determine the critical attributes and characteristics of work orders so that web scheduling can dynamically optimize the chosen work centers with the intent of reducing changeover time. Before we head over to X3 and web scheduling, let's review the key elements necessary in configuring the setup matrix. Setting up attributes, time matrices, and optimization matrices, as well as associating attributes and the optimization matrices to the product and product site, as well as the work centers. Before web scheduling can group and optimize the operations of a work center within the schedule, we must determine what our optimization goals are based on. By setting up the attributes, penalties, and characteristic combinations, we are defining the unique factors to be used by the web scheduling algorithm to achieve our goals. Once we have those factors, we then must assign or associate them to the products and resources to be affected. We do that by assigning attributes to product and product sites, and by assigning the unique optimization matrix to a work center. Let's head over to X3 and learn how to use the setup matrix to define the characteristics that determine our unique optimization goals. Before we dive into the setup matrix, I just want to take a few seconds to revisit the product master, specifically a product's routing. When we talk about changeover time as it relates to the setup matrix, we need to make sure that we set up the times properly in the product routing. As we saw in the stages of changeover diagram, there are many stages or phases that make up the full changeover time. Back in the product master, let's edit the routing of our default product, SFI 027, black standard stool legs. Let's select site NAO12 and then jump down to the routings section. From here, we'll scroll over to the time columns for the black paint operation in the routing. Here you can see we have no values defined for setup time, preparation time, waiting time, or post-op time. Because we are using the setup matrix to account for all aspects of changeover time on this operation, we do not want to add a value to these routing times, just the run time only. So, if you are using the setup matrix to optimize a resource, that resource within a routing does not require any other time value except the run time value. I may be stating the obvious, but I wanted to make sure that that was clear to everybody. Let's head back to my X3 homepage and continue with the setup matrix. From my homepage, let's select the landing page, My Concepts. Here, I've set up a visual process map to give us quick access to the key functions we need to configure the setup matrix. Remember, the setup matrix provides us with the ability to group and optimize production work centers to reduce the amount of changeover time required. But to achieve specific optimization goals, a bit of configuration is needed, which can be broken down into two aspects: setup and associations. Let's start by reviewing the setup matrix's required setup functions, which focuses on three areas: attributes, time matrix, and optimization matrix. Step 1 is to create the attributes we'll use to achieve our grouping and optimization goals. These are characteristics that will be used to determine the changeover time. Here you can see I've created an attribute based on paint colors. The next step is to create a time matrix based on your attributes. Using the paint attributes, I created a grid of attribute combinations and required changeover times for each pair. Notice that a global value can be set for same or different attributes, as well as specific values for each attribute pair. Step 3 is to create an optimization matrix for the specific work center or work centers I want to be optimized. The optimization matrix can be one or more time matrices in combination used to determine the calculated changeover time. Notice that you can define whether the changeover time is calculated based on a maximum or cumulative value. Now that we understand the necessary setup elements, let's make the required associations for the setup matrix to work. The required associations need to be made in the product and product site, as well as in the work center configuration. Let's look at how to associate attributes to a product and product site. Within the product master, I've filtered my selection to only show products related to stools, and my default product is SFI 027 black standard stool legs. For a product like SFI 027 that is impacted by our optimization goals, we need to define the associated attributes in both the product and product site. If I jump to the attributes section of the product, you can see I have assigned an attribute of color with a value of black. If we select the product site, and jump to the attributes, we see the same selection. Defining the attributes sets the product-specific characteristics to be optimized. You must create both product and product site associations for the setup matrix to work. Finally, we need to make the association between the specific work centers and the appropriate optimization matrix. Here, I've also filtered my work center resources to only show those resources related to manufacturing stools, and my default work center is Mac 101, Painting Robot 1, my old painting robot. If we jump to the optimization matrix section, you see that I've associated the paint colors matrix to this work center. This determines the way changeover will be calculated. Once the X3 setup and assignments have been completed and synchronized to web scheduling, our configuration is complete. Let's head back to my X3 homepage and the Scheduling tab to access web scheduling and check out how the optimization engine works. Let's enlarge web scheduling to a new tab and make a few adjustments to the screen. I've already logged in, my resources are locked, and I have an active scheduling simulation. Remember, we want to see the results of the configuration we did in X3 on grouping and optimization. From the resource tree, let's select the Work Center group, Stool, Manufacturing, Painting, US. Here, we see our two optimized resources. We applied our optimization matrix to these two work centers, so that will be the best way to see the results. Let's adjust the scheduling horizon and make sure we're seeing it between the 17th and the 26th. The 17th is the sweet spot, so let's adjust a little bit and zoom in until we get a good view. That gives us a clear view of where the bulk of our paint work orders reside. From the production Gantt on Paint Robot 1, if we select the work order tag in the first position, we see that it highlights the work order in the fishing pond. The work order is for yellow standard stool legs, and the resource is Paint Robot 1. It has an attribute of yellow and a changeover time of 1 hour. This is because of the time matrix we set up in X3. The previous work order was white. The current work order is yellow. The time matrix determined that it should get 1 hour of changeover due to switching from white to yellow. From the production Gantt on Paint Robot 1, as we click on tag 3, we see changeover time. For tag 4 and 5, there is no changeover time. We are optimizing by paint color, and the tags are all black. If we grab tag 4 on Paint Robot 2, and drag it to position 6 on Paint Robot 1, web scheduling dynamically recalculates the changeover down to 0 because that tag is also black. Let's fix the tag to the resource. Set the priority sequence, and run automatic scheduling. This keeps the tag on the chosen resource and keeps the sequence. From the Reports menu, let's select the Loads report and apply a date filter. Let's select our paint work group and let's select Mac 101 Paint Robot 1, our old paint robot. The report shows the total load for Paint Robot 1 on the 17th. If we scroll down, we can see a breakdown of the machine's load by time category. Running that scenario allowed us to manually adjust the plan, force the change, utilize optimization to quickly minimize changeover, prioritize our preferred sequence, and then analyze the impact of the change. That, in a nutshell, is a summary of what we wanted to see. Web scheduling reacting in real time to optimize a group of work orders based on defined attributes and reduce changeover. Very powerful. Let's head back to our presentation to wrap up the session. Before we close, I want to mention that many of the concepts we discussed today are outlined in the book The Goal, written by Eli Goldratt. Eli Goldratt is the father of the theory of constraints, which states that any manufacturing environment is a series or chain of interdependent events. Within that chain is the weak link or constraint that limits the production process. Determine the constraint or weak link, exploit it, optimize it, subordinate all other factors in production to it, always strive to increase the capacity of the weak link, and the impact is improved throughput, on-time delivery, and improved profitability. If you enjoyed the web scheduling series so far and are interested in some of the concepts we've discussed, read The Goal. I recommend it highly. So let's wrap up the session. As we do, recall that we introduced the concept of changeover and learned that changeover time is defined as the time elapsed from the last good part of the previous run to the first good part of the following run. Changeover is not a simple process and can be more thoroughly understood by breaking it down into more subtle stages. Reducing the overall time spent on changeover by recognizing and improving all stages ends up saving time and money while improving throughput. We also learned that X3 and web scheduling provide for the attributes, penalties, and characteristic combinations that define an enterprise's optimization goals. Finally, we reviewed a demonstration of how X3's setup matrix affects work center capacity through optimization and sequencing in web scheduling. To close, managing and reducing the impact of changeover can drastically impact manufacturing productivity. How does it do that? Here are some, but not all, the ways it does. Thanks for joining me for this session, and look for more interesting sessions regarding web scheduling to come.